Now let's look at the notebook. So here, as usual, let's import the packages first. So we import NumPy SMP, pandas as PD, AP module as AP. And now onto the loading of the dataset. So today the dataset will be the iris dataset. That's actually a very famous dataset. So if you pick up any machine learning textbooks, like about coding, for a majority of them, you will find that they are using the iris dataset to do a introduction as an introductory example of machine learning algorithms application. Now, also let me introduce the commonly used machine learning packages that's available via Python. So one package is Scikit-Learn. So that's the package we're going to deal with today. And the other two packages are TensorFlow and PyTorch. So Scikit-Learn is more about general machine learning algorithms. And TensorFlow and PyTorch, their competitive advantage is more about deep learning, so the neural networks. The TensorFlow is developed by Google and PyTorch is developed by Facebook. Now back to the iris dataset. So for the iris dataset, it contains, in the dataset, we actually have 150 observations. So that's because we actually have 3 categories, and each category has 50 instances, or each category has 50 observations. And each of the class is representing a type of the iris plant. So those 3 iris plants are the Setosa, versicolor, and virginica. So that's our labels of the dataset, or that's our outcome variable for the dataset. Then the dataset also has 4 features. So the 4 features are about sepal and petal. Basically, sepal and petal are just different parts of this flower. So the 4 features are sepal length, sepal width, and also petal length and petal width. So here it's a graphical visualization of this dataset. And here we are only visualizing according to 2 features. So the petal length and the petal width. So here the blue group is Setosa. The orange group is versicolor, and the green group is virginica. Now let's click onto this link here. So the complete list, that's a complete list. Oh, sorry, I forgot to mention that this iris dataset, it's actually a dataset that's already embedded in Scikit-Learn. So as I said, iris dataset, it's already embedded in the Scikit-Learn package. And the complete list here, that's actually all the embedded datasets that's already in Scikit-Learn. So you can see that we have iris plant dataset, so just the dataset we looked at earlier. And we have diabetes dataset. And if you scroll down a bit, we also have the California housing dataset, etc. Now let's get back to the notebook. So that's just an introduction of the iris dataset that's embedded in Scikit-Learn. Now let's import the dataset from Scikit-Learn. So what we do here is that we, from scikit-learn.datasets, import load iris. So that's the name for this iris dataset. And we just let iris being equal to load iris as frame equals to true. So here we are so as frame equal to true means that we are loading the iris dataset as a data frame. Now, if we select iris.data, that's going to be, so data is a property of the iris object, right? And that data property will be containing the 4 features of all our 150 observations. So, for example, you can see that the first observation has sepal length of 5.1, sepal width of 3.5, and so on and so forth. Now, let's scroll down to the next cell. So here we are selecting the target property of the iris object, and that's going to be the outcome variable. So that's going to be our labels. As I said earlier, we actually have 3 categories for our outcome variable. So that's going to be like setosa, versicolor, and virginica. So we are representing those 3 categories using 3 numbers. So setosa is denoted as 0, and versicolor is denoted as 1, and the virginica is denoted as 2. So of course, technically speaking, we only have 1 outcome variable. So that outcome variable is the iris type. And for that iris type, it can take 3 possible values. So either setosa, or versicolor, or virginica, so 0, 1, or 2. So that's the data loading part. Now, let me introduce you guys to the Scikit-Learn 4-step modeling pattern. So essentially, whenever you are dealing with Scikit-Learn, the workflow typically would contain 4 steps, and I will be introducing you guys to that 4 steps procedure using perhaps the simplest supervised learning algorithm, k-nearest neighbors, so KNN.